Whoops, there we go. Okay, so here we have this equation, 2 equals 162 times 3 to the 2x plus 5. What would you do first here? Where would you start? Yeah.
Divide by 162 times 2.
Absolutely, yes. So when you are thinking around changing the base, you can only do so once the power or powers have been isolated. This power, 3 to the 2x plus 5, has not been isolated. It's being multiplied by 162. So the first thing we're going to do is divide both sides by 162. Okay? Now, does this simplify? 2 over 162? Yeah, what does it become? 1 over 81. Okay, now this is quite good because although we have this fraction here, which is going to be a little bit of an extra step, if I focus just in on the denominator, I can see, oh, 81 can be written as a power of 3. Right? What would the exponent be? 3 to the what equals 81? Three to the what equals 81? 3 to the 4 equals 81. Okay? How many people don't think that they could do that in their head? Sweet. Thank you for volunteering because I'm sure that there's way more people that also feel the same way. So I want to give you a strategy for if you don't know 3 to the what equals 81, how to figure it out. And really, the strategy is just test things out on your calculator, right? So you should hopefully know what 3 to the 1 is. It's 3. 3 squared, 3 times 3 is 9, right? From there, if you're not sure, you can just test stuff out. So go like, I don't know, 3 to the 5. Oh, that's too high, right? 3 cubed. Too low. So I'm going to try 3 to the 4. There we go. Okay, so you can do a little trial and error there. You don't have to know all of these powers in your head. Okay? All right, so I am going to replace the 81 with 3 to the 4. Okay. So on the left side, this 1 over 3 to the 4, is that base 3 yet? No. How could I make it base 3? Yeah. Yeah, if I bring it up to the numerator, which is what I want, now the exponent becomes negative. So this becomes 3 to the negative 4 equals 3 to the 2x plus 5. And now this is perfect because at this stage I can drop the bases. And I end up with negative 4 equals 2x plus 5. Okay, and this is a linear equation, so I'd probably start by subtracting 5 from both sides. And I got negative 9 equals 2x. Divide by 2. Okay, so x equals negative 9 over 2. Okay, now if I wanted to verify this, then remember verifying the original side of the equation. So I have a left side and a right side, right? My left side's just 2. My right side is 162 times 3 to the 2x plus 5. And when you're verifying, if you want to convert that into a decimal, negative 4.5, right? Sometimes it's easier to plug a decimal value into your calculator than an actual value. So the left side's already simplified. That's already just 2. This is going to be 162 times 3 to the power 2 times negative 4.5 plus 5. Okay, so I'll take out my calculator again. and I'm going to go 162 times 2 to the power, in brackets, 2 times negative 4.5 plus 5. Close the bracket. Uh-oh.
162 times 3.
Oh, shoot. Okay. 162 times 3. Guys, stop me earlier next time. To the 2 times negative 4.5 plus 5. All right. Phew, there we go. So that is also equal to 2. But if I didn't get the right thing, then I have to just go back and try and find my mistake. And actually, if you verify and you're like, I know I got this wrong, but I can't find my mistake, that actually tells me that you have quite a good understanding, right, of equality and what it means to solve an equation. So put that down, right? That's valuable. I like seeing that. And this is 2. So we get that the left side equals the right side. That's what we want. Okay? All right, so I would like you guys to try these questions. There's 4 of them. And then we're going to talk about 2 more together, and then that'll be it for today. So up to this point, we have learned one way of solving an exponential equation, okay, which is to change bases. Problem is that only works some of the time. It only works when you can find a base that will work for both sides, right? So we have other ways of solving as well, and we're going to talk about one of those today. The third way that we're going to learn in this course, we have to wait a little bit because the third way actually involves logarithms. So we'll look at logarithms first, then we'll come back and revisit exponential equations and use logarithms to solve them, okay? But we can use, we can solve them graphically at this point using technology, okay? Now, we're not going to get an exact value because when you solve graphically, you get a decimal, but it's a pretty good approximation. It's better than and more accurate than if we just used a number line and looked at powers of that base to get an approximate or an estimate of the answer, okay? And that's what we looked at yesterday. So, for example, determine the solution for x to the nearest 10th in this equation. 12 equals 5 to the x. Now, I'm going to change this equation slightly. I'm going to change this, instead of to the nearest 10th, I'm going to change this to the nearest 1,000th. Okay? And I'm making that distinction because if you were asked to determine a solution to the nearest 1,000th, there's no way that you can use a number line to approximate that. You will not be accurate. The best that you can do with a number line is the nearest 10th. And even then, you may be wrong, but as long as you're close, it's fine. If you see this sort of thing, you got to approximate to the nearest 1,000th, you have to use another method. Okay? So what we're going to do here is we're going to graph this. And what we're going to do is we're going to graph each side of the equation as a separate function, as a separate graph. And then what we can do is look for the point of intersection. Okay? So the idea here is graph each side. So like y1 equals 12, y2 equals 5 to the x, right? And then we're going to look for the point of intersection. The x value of the point of intersection is our solution. So this will actually also be a really good review of how do we show our work graphically. So pull out your calculators, go to y equals. I'll do this one on both. You probably have your plot turned on right now because the last time we used these we did regression. So you can go ahead and turn that off. So if you see this, right, and that's highlighted, go back, hit enter again, and then it'll be turned off. Okay, let me just get my Casio going here. Okay. And then you guys can go ahead and enter y1 equals 12, y2 equals 5 to the power x. Okay, and I'll do that on this calculator as well. So here I'm going to go to graph. And I'm going to delete whatever was in there. And I'll go y1 equals 12. And y2 equals 5 to the power x. Okay, and then on this guy I can hit draw. And on my Casio right now, I don't need to change anything because I can see my point of intersection. As long as you can see it, your window settings are fine. On this guy, let's say I go zoom standard. Okay, I can only see one of them. Why don't I see y equals 12? Yeah.
Windows.
Oh, sorry. Yeah. Do you want to suggest what we have to do?
I increased it to 15.
Yeah. So y equals 12 is actually a horizontal line at 12. Our y max right now is 10. So we got to go into our window settings and maybe make this, 15 is a really good idea. And then we can hit graphs. Okay, and there we go. Okay. On the TI, since I'm here right now, we're going to go second trace to get to that calc menu. We're looking for an intersection. Oh, and then I'm going to go over close to it. Doesn't have to be super close. Hit enter again, hit enter again. And we can see to the nearest thousandth. This is 1.44. This would round up to a 4. Okay, so how do you show that? And by the way, sorry, before we go talk about how to show it, let's do it on the Casio as well. To do it on the Casio, we just hit G-solve and then hit F5 again for intersect, and it just gives it to you. Okay, so there we have it. It's the same on both calculators. I'm just going to use this one to sort of show my work. Okay, so remember when you're showing your work graphically, I want to see what did you see on your calculator, right? So it kind of looked like this, and then there was like this guy and this. And this was the point, did we say 5.44? 5.544, I think. No, it wasn't 5.544. It was 1.5, right? Okay. There we go. Okay. What else do I want to see here? I want to know what equations did you enter? So y1 equals 12, y2 equals 5 to the x. And by the way, you could swap those. You could make y1 equals 5 to the x, y2 equals 12. Doesn't matter. And then I also want to know about your window settings. Right? So x min, x max, x scale. Y min, Y max, Y scale. And if you can't remember what they are, just go in there and hit window and just read it right off. So x min max scale is -10, 10, 1. And then Y is -10, 15, 1. Oh, yeah. Okay. I think my Casio window settings are different because, hold on. It looks different. But again, if you hit the window, you're going to get all the same information. Right? You can see your y, x min, x max. Scale is 1. Honestly, the scale I don't really care that much about, but on my y scale, it's 100, I guess. Okay. The scale just tells you, if you have a little tick along its axis, how many units is that worth. Okay? So the answer to this question, to the nearest thousandth, is x equals 1.544. Okay? And if you try to verify, this is a decimal approximation. We are rounding. So if we try and verify, and the left side is 12, the right side is 5 to the 1.544, right? And we try and do that. No, I don't want to. Okay, whatever. There we go. So if I go 12 to the power 5 to the power 1.44, 1.544. Okay, it's not exactly 12, but it's pretty darn close. Not exactly 12 because I did round. Yes?
If you, like, on a quiz, should we always verify, or will you, like, ask?
No, so good question. Do you always have to verify in a quiz? You only have to verify if I say I want you to verify, okay? However, it's a good personal strategy to have so that you can check your work. That's number one. Secondly, if you know how to verify, right, you can actually solve a lot of multiple choice questions that way, because you just plug in all the options and see which one makes the left side equal to the right side, right? Now, I wouldn't advertise that as your first go-to, but you could probably, on like a diploma exam that covers all of the course, knock off quite a few questions just by using that technique. So it's worthwhile knowing how to do it and practicing it a bit. Okay? All right, questions with that? Okay, so the last thing that I want to talk about is these types of questions, and you've seen them before. It's very popular, which is, here's some work, there's a mistake in it. Find it, correct it. Okay? And there are multiple ways of doing this. Some people like to just look at the work and see if they can find the mistake. Okay? And that's fine, you can do that. But I find people are much more successful usually when they solve it themselves first and then try and find the mistake. And in fact, like I was thinking about this, when you're finding mistakes, it's almost like you're the teacher and you're marking. But when I mark a test, I always do it myself first anyway to make the key, right? So I only start marking once I've made the key. Part of that is that I can see what's right and wrong. Part of it is so that when I'm marking, it's faster for me to see where the mistake is because I've already been through all the steps myself. Okay? And then on top of that, often you are asked to also correct it. And if you correct it, then that work's done already anyway. Okay? So if we have this, 8 to the 2x plus 1 equals 16. What do you think we're going to do first here? Yes? Yes, make the bases the same. What base will work for 8 and 16? 2, right. So I can write 8 as 2 cubed to the 2x plus 1 equals 16 is 2 to the 4. Okay? And then over here I need to distribute. So this gives me 3 times 2x is 6x plus 3 times 1 is 3. Okay? And now what am I going to do? Drop the bases. So I will get 6x plus 3 equals 4. right? And now I can solve. So I'm going to like subtract 3 from both sides. And I get 6x equals 1. Divide by 6, divide by 6. X equals 1/6. Okay? So going back here, where's the mistake? Step 2, right. And the mistake, sometimes people are like, and this is confusing, sometimes people think the mistake's in step 1 because after step 1, that's where you make your mistake, okay? But the way that this type of question is sort of marked is the mistake happens as soon as the equality sort of breaks down, right? So this is fine because this is still equal to that. This is not equal to that, right? Like, or I should actually think more vertically, right? I haven't changed anything here. So there's not going to be any mistake here as long as 16 equals 2 to the 4th, which it does. The mistake is going to happen some point here. So this is good. But this line does not equal that line. So that's where the mistake is. Okay. All right. And the mistake, of course, over here is that this person, Anna, did not distribute that multiplication of 3 to the 1 as well. Okay? All right. Any questions with that? All right. So, oh, there was another step in there. Anyway, we found the first one. That's another thing that I should mention is that oftentimes with these questions, there are several mistakes, but you're asked to identify the first one. Okay, so you got to make sure that you look line by line. Where does the first thing go wrong? All right, so I'm going to stop there for today.